Good morning, everyone. This is Samoche Ajame, and here once again on CircuitWise Academy with our next lesson, which I told you last week that we are going to do, and that's on power and energy in electronics. Okay, and today we are going to go through. I'm going to help you understand what power is and what energy is, and essentially how it comes in the design of electronics and circuitry. Okay, so this is Circuit Academy here once again, and let's dive in. So last week we spoke about AC current and DC current, where I talked about AC current being current that flows in just one direction, and it can commonly be found in batteries, solar panels, and all these other things that I spoke about. If you don't know or you don't remember, you can quickly refresh your mind on the previous video I did on AC and DC current. Okay, and as for AC current, as I said, it's periodically reversing its polarity. Okay, so it changes over time, and these periodical changes can be figured out using the hertz. So I said in Ghana we go by the between 220 to 230 volts, operating at 50 hertz, which means it's changing 50 times in a second. And then we have the US who goes with the 110 volts, and that one is at 60 hertz, changing 60 times in a second. Okay, so we are here to have an understanding of what power is. Okay, so today we will define power as the rate at which electrical energy is consumed or produced. Okay, keyword consumed or produced. So as I said in the first video where we spoke about electricity, we spoke about electricity being the flow of electrons. Okay, this results in a type of energy known as electrical energy. So electrical energy is the energy produced as a result of the flow of electrons. Okay, and power is the rate at which this energy that we are talking of, these electrons, the rate at which they are being consumed or produced. Yeah, the rate at which they are being consumed or produced. Okay, and the unit of measurement for power is watt. Okay, and mathematically power can be represented by the voltage times the current. So the voltage is the potential difference between the positive and the negative terminal. Okay, as the voltage, as I said, determines the flow of the electrons, and the current is the rate at which these electrons are flowing through a conductor at a certain time. Okay, so when we multiply the voltage by the current, we get the power of that specific object or device or anything connected to it. Okay, so energy consumption. How do we define energy consumption? Energy consumption can be defined as the total work done by electrical power over time. Okay, the total work done by electrical power over time, and the mathematical formula for energy is the power times the time. Okay, that one is just straightforward. Okay, so what do we mean by work done over time? So as I said, every electronic device that's connected to, let's say, our wall outlet is taking in a specific amount of voltage and a specific amount of current. Okay, so that specific amount of voltage and current results in that thing having a specific amount of power. Okay, and when we measure that power over an extended period of time, we get the energy consumption of that device, and this energy consumption is what ECG use to charge us. So we are charged per our energy consumptions. So me, for instance, where I find myself currently, we share a single meter. Okay, and the amount that each of us pay is dependent on the items that we use in the room. So if you use items that have a high power rating, what do I mean by high power rating? They absorb or they take in more electrical power than most systems. Okay, they absorb or they take in more electrical power than those. If you use some things like that, the total cost for you tends to increase. Okay, so they take in, they calculate the amount that each person is using depending on these things, and then at the end of the month we combine and then we use them to buy the amount, the units that we will need to help us sustain or survive within the month. So a practical example is, let's use a standard light bulb. Okay, so for a standard light bulb that has, let's say, 10 watts, okay, it's rated for, let's say, 100 watts. Okay, it's rated for 100 watts and is being used for 5 hours. So for that, the energy that that bulb would consume will be 0.5 kilowatt hour. Okay, this is quite simple, this is quite straightforward. Okay, so why do we need power ratings? Okay, what's the essence of knowing the things that I'm talking about right now? So power ratings are very key in the sense of, one, it helps in safety. Okay, it prevents you from overloading a power supply unit. So if you know the power rating for each of the devices that you are using, it prevents you from connecting it to a low power system or high power system. It basically protects you and the device. Okay, one other thing is component selection, and this will be very ideal, or this will come in best when we start doing the schematic and PCB design, where you know that in reading the data sheet we are going to take into consideration the power ratings of the components that we are putting together. Okay, after you are done considering the power ratings of the component that you are putting together, you also consider the power ratings of your entire system. So one of the key things in designing circuitry, in designing and doing all those things, is your power supply unit, because depending on the components that you place, depending on the type of power that you use, there are times that the power supply unit, you have no choice about it. Okay, there are times that you are restricted by the power, there are times that you are restricted by the components. Okay, and I will show you effective ways to work around it. And the other thing is efficiency. We don't want to be wasting electricity in our homes, and I recommend, if you do that, you don't do that. Okay, don't be wasting electricity. Make sure that we have an energy efficient power management system, because we know all these power ratings and as such. So what are AC and DC power rating consideration? Okay, so if we were to get into much details with the theory, which, as I said, this is a practical course, so we are not going to get into much details about it, but you can read about it if you are still interested. AC power use the root mean square value for the voltages and watts. For DC power, it's much straightforward because we have constant voltage and constant current. So we just multiply the constant voltage and the current, and you get the power. So for both calculation, we still use the power is equal to the voltage times the current. Just that in this case, for AC power, the voltage is the root mean squared voltage, and the current is just the normal current ratings for it. Okay, so this is the end of our module 1. So our module 1 was a talk about electricity. We spoke about what voltage is, what current is, what resistance is. We moved on to talk about what AC circuits are, what DC circuits are, what do we mean by alternating and current and direct current. And now we've also spoken about power, energy consumption, power ratings, and all these things. So next up is our module 2, where we are going to talk about types of circuits. And for module 2, the first lesson inside module 2 is opened and closed circuit. For module 2, the first topic is opened and closed circuits, which I'm going to take you through. So that's it for today. I'm very happy to have completed the first module, and I hope to see you guys again next week. And thank you, and have a great weekend.